Imagine it's Friday afternoon, the weekend ahead of you, but now your security team calls to tell you that a severe security vulnerability has just been disclosed. It's a remote command execution vulnerability with a severity score of 9.8 out of 10, which means we have a huge problem. Now it's your job to find out in which projects you're running this software, in which version. And of course, we always have up-to-date inventories of our software, right? Do we? Maybe not. Now imagine how you feel in this situation. You just wanted to go home, to your family, to your dog, or just go into your well-deserved weekend, and now this. Instead of going home, you have to assess the vulnerability, and you have to decide what you're going to do. Do you decide to switch off, to shut down your service because the vulnerability is just too dangerous? Or do you decide to install the newly released patches on all stages on Friday afternoon? Because bad things often happen on Fridays, right? So instead of going home, you have to stay a few more hours, and this sucks. What if I told you there is a solution to this situation? Something like a virtual patch, something that protects your application so that the vulnerability cannot be exploited, something like a shield. And guess what? There is such a thing. It's called a Web Application Firewall. And this is what this talk will be about. We will see what a WAF is, a Web Application Firewall. We will learn why it's a good idea to have a WAF as part of a defense in-depth strategy. And we will see how we at SBB manage WAFs at large scale. And spoiler, we have many of them. But first of all, I would like to introduce myself so that you know who is talking here. My name is Franziska, or Franzi Bu, and I'm a huge fan of WAFs. I've been working with WAFs for 15 years, currently as a security engineer at SBB. And I'm such a big fan of WAFs that also in my spare time, I spend a lot of time with them. I'm part of the OWASP CRS team we see on the pictures here. This picture was taken during our last develop retreat in Budapest, Hungary, last November. We meet in person once a year. And as part of this team, I help write and enhance rules for web application firewalls. And you know what? These rules are also used by large integrators such as Microsoft Azure, Cloudflare, for example. And another cool thing is that we lately had a bug bounty program at Core Rule Set, where ethical hackers tested our rule set so that we can say that the latest rule set is one of the latest we have ever, one of the most secure we have ever published. But now let's dive into this really fascinating topic of Web Application Firewall. A WAF is like a shield in front of your web application. It stops attacks before they ever reach your application. And this means that attacks like ASCII injection, cross-site scripting cannot exploit your application because they do not come through the WAF. A network firewall works at layer 3 and 4, and a web application firewall works at layer 7. So it looks into the HTTP traffic and decides whether or not this traffic is legitimate. And to make this distinction between good and bad traffic, rules are used. And these rules mainly consist of patterns, of regular expressions of known bad traffic, so it's a denialist rule set. And it's very important to understand that a WAF cannot protect from every attack, not 100%, but it makes it way harder to exploit an existing vulnerability. So this was explained at a very high level. Let's go into more detail and have a look at a specific example. In this example here, we have a web server, example.com. This web server has a method, getFile, and this method is meant to download or to get file from the web server's web directory. But now, as part of the get argument file, we see this .. etc passwd. So what happens here now? Now we go back in the file system, we break out of web root, and we can access an arbitrary file on the web server. So as a result, we would get this etc passwd from the web server. Of course, the developer was not thinking of using their method in such a way, but this is how hacking or breaking things work. It's sending unintended stuff at an application and using a misbehavior of the application. And what the WAF now discovers here is this so-called path traversal attack. The WAF says, this .. as part of an argument doesn't look legitimate. It doesn't make sense, so let's better block this. So even if the application had this vulnerability and if the application allowed this, it could not be exploited because the WAF would stop it before it reached the application. Of course, not only path traversal attacks are detected by a WAF. There are many other web application attacks out there. As I said, hacking is using an application in an unintended way and using the application in an unforeseen way. And that's why a WAF tries to protect against many web application attacks, as we see them on the word cloud here. These are the WAF rule groups as we use them in the core rule set project. We see very popular attacks like SQL injection, cross-site scripting. We see very dangerous attacks like remote command execution. We see attacks against the HTTP method itself, attacks against sessions. So we see that the WAF can protect from many web application attacks. But why do we need this? Why don't we just write code in a secure way? Why don't we just develop in a secure way? Of course, we try to do so. We have secure coding guidelines. We have awareness training for developers. We have tests in the pipeline like SAST, DAST, static dynamic application security testing. But it's not possible to always write secure code. Or sometimes we buy software or we download software and there we don't have any control of the code. And that's why we need this additional layer of defense in front of it. So that all sounds very good and reasonable and promising, but sometimes a WAF can also have disadvantages. Sometimes a legitimate request looks a bit like an attack, even if it's not. And this example here is real too, because it's one of the latest false positives I resolved for the core rule set team. Axel is a CLI tool to download files. It's a Unix command, but it's also a German first name. So users complained that they got so-called false positives with the full name Axel Schmidt, for example. So I had to resolve this for the core rule set team. But what do you do if you have false positives in your WAF installations? You can, for example, disable an entire rule, but this would be a big hole in your WAF. So it's better to just remove a specific argument or a specific path from a specific rule so that we can say the tighter these rule exclusions are, the more secure. So I'm pretty sure you're already convinced that having a WAF is a good idea, but I would like to show you with a real example again why we really need a WAF. The story at the beginning of this talk was real. It happened last December. Last December, a severe vulnerability was disclosed where it was possible to upload a malicious file to the web server outside of webroot. And after a successful upload of this file, any command could be sent to the server. This is a remote command execution, and this is really dangerous. And that's why this vulnerability got a score of 9.8 out of 10, where 10 is the worst. So we have previously looked at this example with the // so we are all WAF professionals now, right? So not only we spot now this path traversal as part of the post request, but also the WAF discovers this. So the WAF blocks this request before it ever reaches the vulnerable installation of Apache struts in this example. And in my opinion, this is really good news. This is the typical use case of a WAF. This path traversal detection is a standard rule that is part of every WAF that I have tested. So as soon as I have a WAF in place, I'm protected by default, and this vulnerability no longer affects me by default. So in my opinion, this is a really nice example of the advantages of a WAF. And today, a week ago, a PHP CGI vulnerability was disclosed, and there too, the WAF detected this in the standard installation, and we were covered with a WAF there too. And now, even if there wasn't a standard rule, I could write my own patterns to detect a specific exploit. And of course, I only have this possibility when already a WAF is in place. And this was the case December a year ago when the Log4j vulnerability was disclosed. There we had to write new rules to detect these JNDI patterns. This also happens, but for a lot of attacks, I already have standard rules in place. Now, it's very important to understand that a WAF is there to save us time. It's like a safety net in front of our web application, and it takes away the sense of urgency and pressure. But it doesn't save me from having to patch the application or update the software. But now I have more time to investigate and assess the vulnerability and carefully plan a software update. A WAF is intended as part of a defense in depth strategy, where up-to-date and patched software is just as important as having a WAF and many other parts of a defense in depth strategy. And another advantage is I have very detailed logging and monitoring mechanisms. I have very deep insights into the HTTP traffic with headers, body, and this helps me when, for example, attacks are taking place. So now it seems clear that everyone should use a WAF. Many organizations do, and so does also SBB. At SBB, we are a dedicated team that takes care of web application firewalls. Our name is Network and Application Protection, NAP, and we are about 10 engineers. Do you see the 3 bottles? It's whiskey, yes. And here we see most of our team during our last team event on the Beatenberg last September. And by the way, we will soon have an open position if you want to be on this picture again. So, side note closed. We follow the DevOps approach. This means we not only engineer our platforms, but we also operate them. We work agile and in 2-week sprints. We have WAFs in the public cloud and on-premise, and we have many applications, so we have a huge attack surface, so we need WAFs to protect them. And when many applications result in many WAFs, we need some kind of automation to handle this. We use the WAFs where the applications are located. So for example, if we publish an application on AWS, we use the WAF by AWS. So in the next part of this talk, I will focus on this cloud provider, AWS. We have others as well, and even on-premise, and automation is a little different, but similar. So this is just an example. On AWS, we have a policy that enforces a WAF in front of every endpoint that is published. So no endpoint can be published without a WAF in front of it. And I think this is pretty cool. But as a result, we have around 200 WAFs on AWS alone, all stages included, but still. And as you might think, this requires a high level of automation. This is the big picture of how we manage AWS WAFs. We have, for the deployment of the WAF policies, we use the AWS Firewall Manager. So we have WAF policies stored locally. Note first, we have a privileged account that can deploy into the various customer accounts. And we have a default WAF policy that is deployed to every WAF. And these default policies are stored centrally. And as we have already learned before, sometimes false positives happen, sometimes exclusions have to be written. And these are stored as policies as well. And these are stored at the same place like the WAF default policy. This is written in Terraform code, infrastructure as code. And now if there are changes to these exceptions, and if they are merged into main, they're automatically deployed into the corresponding customer account with a Jenkins. We have different customers. Some customers can tune a little bit on their own. They can, for example, change exceptions, like we see this in this example here, change a path of a specific exception, cross-site scripting exception in this example here. And they open pull requests, and then we approve them. And it's because it's always good to have this four eyes principle. And we have other customers that fully rely on our service to tune their false positives. And there too, we enforce this four eyes principle, but internally in the team. In the example here, we see that an exclusion is changed. The path changes a little bit. And as I said before, this is stored as Terraform code centrally. And this change will be deployed as soon as this pull request is merged into main. From time to time, rules need to be updated because new undiscovered attacks are discovered. And like I said before, this was the case Log4j a year ago. And also AWS updates their rule set from time to time. And of course, we as customers, we always want to have the latest rule set, and we would like to test them. So we check for new specific versions daily, and we update to the latest specific rule set on non-prod stages within a day. Then we let our customers test. When big changes occur, we ask them to do so via blog post. And then between 1 and 3 weeks later, AWS releases this latest specific version as their current rule set. So it will be deployed on our prod stages. And now the advantage is that when AWS releases them as current, We already tested this for 1 to 3 weeks on non-prod stages. And of course, if then we have any problems, we can revert back to a specific version again. So this was all explained at a very high level using AWS as an example. Like I said before, we have various products, and automation is similar there. At SBB, we already solved some challenges, but always, like always, there is room for improvement. But this is what makes our work interesting. And one challenge we have is that we have a very diverse environment. We have a lot of WAF products. And the problem is this makes engineering and operation a bit more difficult because it needs a lot of expertise for the various WAF products, and they differ. Another challenge is that the logging and monitoring is not at the same level for every WAF product we have. And I personally would like to have even more insights. But yeah, these are challenges. I don't have a solution right now. They are still open, but like I said before, this is what makes the work interesting. We need some challenges. But even if not everything is 100% perfect, we've still gained a lot of experience, and I hopefully can pass on some valuable tips or key takeaways for you. First of all, and most important, use a WAF. We now know why. Get involved into the projects early so that you have enough time to test the interaction of the various components, because we have learned before that sometimes false positives need to be tuned. Do that early and not in production. What we do, we block by default from the beginning. And if we didn't do that, nobody would dare to switch on the WAF in production. Store the WAF policies centrally. Do not change them on the various endpoints in the various WAF policies. This sooner or later will be a huge mess. Ensure that you do the changes only via repository. And what we could do, for example, if tomorrow a new attack is published, we could relatively quickly deploy them to our various WAFs because we have this automated deployment in place. So one more thing. This has nothing to do with WAFs, but I'm a big fan of it too. I had to write the last postmortem last week, but they have helped us in the past for many times. Do postmortems, live a blameless postmortem culture. Every time we fail, no matter how big or small the failure was, we analyze why it happened and we improve. With specific action items, we try to prevent exactly this failure from happening again. And this is how we get better and better every time. Unfortunately, I cannot share internal documentation with you, but because I'm an OWASP CRS developer, I can share these links with you. If you are interested in learning more, you can go to corelset.org/docs, and there you'll find very good documentation about WAF rules and WAFs in general. And if you want to talk to a WAF and see how it behaves, how it responds, how it blocks, you can use our sandbox. And now when I say our, I mean the CorelSet team. You can talk to the sandbox and you can see if it blocks or not. You can use the 2 curl requests I have written here. The first one is the example with the path traversal, and you will hopefully get 2 rules that block you. And the second curl example is the false positives with the full name Axel Schmidt. And CRS 4.2 and above, this should not be blocked anymore. This should be blocked at a higher level of protection. So in summary, I really recommend using a WAF. They can buy you time to properly investigate and assess the vulnerability and carefully plan a software update or a patch. A WAF doesn't save you from staying up to date and secure, but it takes away the sense of urgency and pressure. A WAF can protect against really dangerous attacks, so it's like a safety net, and in my opinion, should be part of every defense in-depth strategy. So if you have any questions, I would be very happy to answer them during a coffee after the talk. Yeah, thank you very much.